Let's start with RIP protocol. That is a distance vector protocol used to facilitate the exchange of routing information within an autonomous system. So RIP uses hop count as its metric for determining the best path to a destination. So with a maximum limit of 15 hops. Okay, that is important. Just keep in mind, if you are using RIP, we have a limit of 15 hops only. Okay, here routers using RIP to send updates every 30 seconds to their neighbors, sharing their routing tables. Okay, as I told you, RIP convergence can be slow, which may lead to routing loops even, and it employs mechanisms such as split horizon, route poisoning, and hold down timers to mitigate these issues. Okay, there are two main versions of the RIP. They are RIP version 1, that is classful, and we have the RIP version 2, which is the classless version of the protocol. So how it works? RIP uses the Bellman-Ford algorithm, okay, for metric calculation, and the actual metric is again hop count. Okay, so RIP can support a maximum hop count of 15 routers. So, for example, if you want to reach, okay, let's say I have this network in here. So you could see it is 10.0.0.24, right? So if you want to reach this network from this router 1, you have two different options, right? The packet can go from here, or it can go from here also, right? So what is the best path? As per RIP protocol, the best path is the one on the above. Why? Because I have only one hop to reach my destination. Okay, I just can reach to this network by using one hop. Okay, and that is this router 2. On the other hand, this path is a worse path compared to the above for RIP protocol. Why? Because we have two hops to reach my destination for the below path, right? So RIP metric is the hop count, but keep in mind that does really make sense. For example, yes, maybe I am passing through only one hop, and in here I am passing two hops, but maybe this path is using much faster cabling ISP networks, but above path is using very old-fashioned slow ISP circuits, right? It's very much possible, and RIP does not care of it, okay? RIP is only looking at the hop count. So now let's see how RIP is establishing the routing table. In the first place, you could see that we have router 1, router 2, and router 3, and the routing table will include only the directly connected networks, right? For example, router 1 has a directed connected network to its Fast Ethernet 01 interface, and this network is 10.41.0.0, and it is in the routing table of the router 1, and it has another network 10.42.0.0 directly connected to the Fast Ethernet 00 port. Okay, so that is in very initial stage. Here there is no routing protocol running still, and you didn't teach anything to this router is in a static routing way also. Okay, so when I enable RIP and RIP starts working, This is how it happens, okay? So first of all, routes are exchanged between neighbors and routing table begins to grow, okay? So for example, I have my router 3 in here, okay? Router 3 has this network connected to FAST01 and this network connected to the FAST00, right? So router 3 will inform router 2 mentioning that, hey, router 2, I have this 44 network, it is connected to my Fast Ethernet 01 network. Then router 2 will go ahead and install this network to its routing table, and since it's coming from router 3, how it is reaching to router 3? Pay attention, it's reaching by Fast Ethernet 01 and it will install interface as Fast Ethernet 01 and the hop count will be 1, right? Because it's coming from the router 3. On the other hand, another routing update is coming from router 1 to router 2, okay? It is informing that, hey, router 2, I have one network in here, 1041.00, which is connected to my FAST01 interface. Just go ahead and install to your routing table, please. Okay, since it is coming from router 1, it will add it as a hop count 1, right? And then what will happen? It will install this to its routing table 1041.00. How I am reaching? I'm reaching by using my Fast Ethernet 00 port. That makes sense, right? On the other hand, router 2 also will inform router 1 and router 3 about its networks. And these guys will start installing the networks of router 2, which they are not aware, and they will install the hop counts as well. Okay, that is how it works really. In the final stage, what will happen? Every router will exchange these routing tables with the neighbor routers. Okay, so I just want you to pay attention to one thing in here. Yeah, for router 1, I have this one, this one, this one, and it learned 1044.00. Yeah, that is the network over there. How it happens? It happens in this logic. So router 3 advertised this network already to router 2, right? And router 2 has updated its routing table by mentioning this route is behind router 3 and router 3 is just one hop away from me and I am reaching it by using Fast Ethernet 00. Okay, and what happens? Router 3 is advertising this same network to router 1 as well. Hey router 1, I learned one network from router 3 and this is 1044.00. This is one hop away from me. That means I'm reaching it only I'm reaching it only going through the router 3. Since it is one hop away from me, you should install it to your routing table. It will be reachable to you by using FAST00 because you're reaching me by using FAST00, and it is 2 hops away from router 1. Okay, because since the network is 1 hop away from router 2, this is gonna be 2 hops away from router 1. Okay, that is the whole logic of RIP protocol and how the routing exchange and the routing table is being established. How we configure it? Okay, that is pretty much basic, to be honest. Okay, so here I have this network. We are having a look how I can configure RIP for router 1, for example. 172.16.10 and 10.42.00 are the networks for router 1. For router 2, I have this network as well as this network. Router 3, I have this as well as this network. So configuration is very much basic. You just, in the config mode, of course, you just type router RIP. Then you define the version of the protocol that you want to run. It will mostly be version 2, router RIP version 2, and then you just go ahead and type the networks that this is connected to. Okay, in the class B you are writing like 172.16.00, and since this is a class A network, you are typing only the class A network 10.0.0.0. Think like this is this is using a /8 subnet mask. This is using a /16 subnet mask. Okay, so on the other hand, for router 2, it is only connected to this networks and this network, which means it will be enough only you just type 10.0.0.0, because this 10.0.0.0/8 will include both. Okay, and for this router 3, I need to type 10.0.0.0 as well as I need to type 192.168.1.0. Okay, so how you are configuring is really based on the subnet mask, okay, classes. So if you see some network starting with 10, basically you are putting 3 contiguous 0. If you see something with the B class, you are putting 2 zeros at the end, and for the C class you are putting just 1 0 at the end. That's it. How I am doing the verification? The command I'm using in here is show IP protocols. Show IP protocols will show you which routing protocol you are using in this router. Okay, in this case you will see that the protocol you are using is RIP, and each router is sending updates every 30 seconds. Okay, if there is a change or not, everything will be updated each 30 seconds to the neighbors. So you will be able to see one more thing, for which networks this guy is routing for. Okay, for example, router 1 is routing for these 2 networks. Okay, so let's continue. We have one more command for verifying the RIP configuration, and that is show IP route this time. Show IP route will show you the entire routing table of this router. For example, this is run for router 1. Okay, here I could see some multiple different types. I have type C. Type C is showing the directly connected networks, and this guy has this network and this network which is directly connected. We have type L as local, and also we have type R. Okay, what is type R? Let's have a look in here. Type R is RIP. Okay, which means this router 1 has learned these networks, 1043, for example this one, as well as 192.168.1.0, which is this one, by using the RIP protocol. Okay, So you will see the next hops, you will see the timers, for how much time this route was active. This information also will be available. And if I also run the same command for router 2, I will see something very similar. Whatever directly connected and local routes will be appearing in here. And this router 2 has learned 2 different routes from the RIP protocol, and they are 172.16.0.0 network, which is this network, and also it learned this network, 1.0 network, right? And you could be able to see, this is via 10.42.0.1. That is this interface IP address of router 1. That is the next hop. And for router 2, how I am reaching this network is via 10.43.0.3. That is this interface IP of this router 3. And on the other hand, these interfaces for 10.42, this is gig 00. That is the local interface of this router 2. This is showing how I am reaching from which interface I am reaching the destination network. And for 192.168.1.0 network, I am reaching from my gig 01 interface. Okay, this is how it looks like. And we have RIP-NG. That is an extension of RIP, guys. It is just for supporting IP version 6, and the maximum hop count is still 15. There's no change. And the configuration is again very much, basic, I would say. You just go ahead and enable the IP version 6 unicast routing for each and every router you are seeing in here. Then there is something different in here. Okay, if you want to enable IP version 6 RIP, what you are doing, you need to go to the interface level. Okay, for router 1, I have gig 00 and gig 01 interfaces. I need to go to these interface levels, and I just need to run some RIP related commands, IP version 6, and you just define some name and you put it like enable. Okay, that is the command. So for example, for router 2, what will happen? Again, you need to enable the unicast routing. You need to go to the interface level, gig 00 and gig 01, and then you need to run IP version 6 RIP, the name, and you type enable. That's it. How you could verify the IP version 6 RIP? And it is, again, you can type the show IP version 6 protocols this time. Okay, pay attention to that. And it will show you the RIP protocols and which interfaces are running the RIP. As well as, again, you can run the show IP version 6 route command to see the IP version 6 routing table, and you can verify the networks which are learned by using the RIP protocol.